welcome to part 2 of our crash course on fluids. So in part 1, we had talked about compressible and incompressible fluids, the pressure in compressible fluids, as well as a couple of examples. In today's video, we're going to look at pressure in incompressible fluids, as well as a couple of examples to explore. So let's get started. So let's take a closer look at incompressible fluids and pressure. So right over here, I have this container of particles. Now those particles can be any liquid. They can be juice, they can be soda, they can be water, they could even be oil. And they're in a container. So those particles are bouncing off of those walls, but then we are going to add a piston. And so a piston, although it is pressing down on that fluid, the fluid is not compressible. So the volume's not going to change, but that doesn't necessarily mean that nothing happens. Because when we deal with applying pressure, now what's happening is that those particles are now bouncing off of that piston as well. And so when a force is applied to an incompressible fluid, its volume remains the same, but its pressure increases. The more collisions, the higher the pressure of the fluid, like we discussed in part 1. The same is true in incompressible fluids. Those particles inside that container are now, there's now an extra surface to bounce off of, so more collisions. So let's take a look at our first example, which is a tech object called a hydraulic jack. And so it's really important to remember that incompressible fluids maintain their volume, but can move due to changes in pressure. So right here, we have a hydraulic jack, okay? And so it's currently at equilibrium. Now, a hydraulic jack is usually two cylinders that are connected. And what happens is that they have fluid within them, so oil or water, and that fluid within there's a pressure that's applied. And so what's happening is that on one end, we are going to apply pressure with a piston. And so what's going to happen is that's going to apply even more pressure to that incompressible fluid throughout the system, throughout the jack system. And so it's going to go down and around. And then what you notice on the other side is that the other side, there's a space for that fluid to rise because it's not being limited by another piston. And so that's allowing us to move that fluid upwards. And so this is actually kind of a cool thing because it's often used to lift heavy objects. When you play with the diameter of the tube of the hydraulic jack, you can play with pressure and you can also play with how much of a load you can lift. And so that is actually something that you'll look at in secondary 4. So to give you kind of a final look at what the hydraulic jack can do, obviously we see that we have the fluid that is being compressed. And the movement is going out towards the space that doesn't have the piston blocking it. And so what that does is it's lifting whatever load is on the other side. So now let's look at another incompressible fluid in our body, blood. But first, let's answer a question. Which heart structures are identified in the following image? Is it A, the atria, or B, the ventricle? The answer is A, atria. So let's look in more detail about how blood, which is an incompressible fluid, circulates throughout the body. And so in order to do that, we need to look at our heart. So the top chambers of the heart are the right and left atrium. Like we discussed in the last question, they're the top parts of the heart. Blood fills the atria through the vena cava, which is the right, and the pulmonary vein to the left. And so blood flows into the ventricles. And then what happens is blood is pushed out through the aorta and the pulmonary trunk. Blood moves due to a variation in pressure, and so we're going to be exploring that further. Which statement correctly describes the blood pressure in the heart? Is it A, when the atria are filling up, the blood pressure in the atria is lower than in the ventricles? Or B, when the atria are filling up, the blood pressure in the atria is higher than in the ventricles? The answer is B. When the atria are filling up, the blood pressure in the atria is higher than in the ventricles. So when blood enters the heart, it's going to fill each atrium and starts pushing on their walls, applying pressure. Now remember, in fluids, any type of fluid wants to go from an area of high pressure to an area of low pressure. So right now, pressure is growing in the atria. And what's going to happen then after that is that the atria is going to contract, and it's going to push the blood into the ventricles, because the ventricles at this point don't have a lot of blood in them. So they are an area of low pressure. And so what's going to happen is that they're going to the blood or incompressible fluid is going to pass through a one-way valve or one-way valves from the atria into the ventricles. And we want to make sure that we understand that it's one way, because we don't want blood rushing backwards. We don't want blood refilling the atria. Which statement correctly describes the blood pressure in the ventricles? Is it A, when the ventricles contract, blood pressure increases? Or B, when the ventricles contract, blood pressure decreases? The answer is A. When the ventricles contract, blood pressure increases. So now we have these ventricles that are filled with blood. And they have openings, remember, that are covered with valves, those one-way streets, so that we don't want the blood to go backwards. And so when the ventricles contract, because they are now at an area of high pressure, they are forcing the valves open towards the aorta and the pulmonary tank, which are the exits out of the heart. So then blood is now going to flow out of the heart to the other vessels. So an area of high pressure to an area of low pressure is where the fluid is going to go, out of the heart. And so the cycle continues, right? Blood continues to come in the heart and exit the heart. So the atria is going to fill up again, and the pressure is higher than in the ventricles. Then the blood is going to flow into the ventricles with the contraction of the atria. Ventricles are then going to fill up. They're going to contract, increasing the pressure, and the blood flows out of the aorta and the pulmonary trunk. And you have to remember that every time it moves to a different chamber, the blood moves through a different chamber, it is going through valves that are one-way streets, right? They are there just to open, and that is all. They want to go from an area of high pressure to an area of low pressure. That is their job. So we just want to make sure that we remember that those valves are one-way doors. So let's do a quick couple of reminders before we finish our video for today. So remember, when a force is applied to an incompressible fluid, which is a liquid, its volume remains almost the same, but its pressure can increase and will increase. Blood is an incompressible fluid, and blood moves through the heart and into the arteries due to a variation in pressure and one-way valves. And that brings our journey with fluids to an end. So I hope that you check out any other videos that help you review, or if you need to go back to video number 1 to make sure that you understand all fluids, both compressible and incompressible, make sure you do it.